Hey everyone, Big Mac here. So I thought I would do another QualQuest video today. This one should take considerably less time than the last one. So today we are asked to integrate this thing here. We have 1 over x squared to the 1 minus 1 over n power dx from the bounds of negative infinity to infinity, and then we want to evaluate that as n goes to infinity. So, some of these parts might look familiar, but how can we trying to find a way to, make these things solvable? So we have a couple tools for us. In order to solve this integral, one thing that's going to help us tremendously is known as the dominated convergence theorem, the DCT. Basically, what this means is that if we can find a function g that will bound our limit function, which we don't know, if we can find such a function g that is finite within the bounds, then we can essentially switch the integral and the limit. So we can take the limit on the inside, then evaluate the limit, and then just take the integral. Here we have a quick graph of the function 1 over 1 plus x squared to the 1 minus 1 over n power. Basically, as n becomes really large, we're going to go down to this asymptotic thing here. Whereas, if we have n equals 3, let's just use that one for instance, then we know that the function is always greater than at all points, or at least equal to at 1. So let's try and use the case of n equals 3 as our bound for the case as n goes to infinity. Okay, so actually we don't know how to compute this integral in itself, but one thing we can do is we can make an upper bound approximation on it just by using some, Riemann left-hand sum notation here. Well, I guess I could make it left-hand side on the right, or on the right half, and right-hand sum on the left half, if that makes sense. So, but basically this integral is going to be roughly this summation formula here. And thus, we have in the denominator, we have n squared to the 2/3 power. So the leading coefficient is going to have, or the leading power is going to be in terms of n to the 4/3 power. And if you remember, any summation of 1 over n to a power, that sum will converge as long as the power is greater than 1. So since we have 4/3 as our lead power, then we'll be okay. So then we know that this sum converges, and since we know that the integral is about twice the sum, then twice the sum converges, and thus the integral will also converge. And thus, since the dominated convergence test found a function that was greater than our desired one and had a finite integral, then we can switch the limit and the integral signs here. So we now take the limit on the inside as n goes to infinity, so 1 over n will basically vanish. And we are left with, down here, the integral of 1 over 1 plus x squared dx from negative infinity to infinity, which you may remember is the arctan or inverse tangent function, which we evaluate between infinity and negative infinity. And we get a resulting value of pi, which happens to be one of my favorite numbers. Alright, so this is just a quickie koala. Get it? Get it? Because I know my cartoons. Get it? Because it's a qual, but it was really terribly quick. So, yeah, okay. Big Mac saying, later.